YouTube. What we're going to be talking about today is a fairly simple field expedient or homemade antenna that's going to be good for VHF and UHF frequencies for your handheld radio. If you're wanting to have an antenna that's going to transmit a little bit better than the little antenna that came on your handheld radio. And usually making a field antenna is pretty easy for people that are fairly confident in soldering and fairly confident in making radio type connectors onto cable and stuff like that. And that's not who this video is for. This video is not for ham radio people or people familiar with how to make antennas. This video is for people that have no idea and perhaps want to use some stuff that's just laying around their house that they're not using anymore, and maybe like $4 of stuff on Amazon, and to be able to make an antenna that is maybe going to transmit a little bit better. So the basic premise of antennas in general, it's just kind of a background, is all antennas are what we commonly refer to as a dipole. And we could think of that as like a positive and a negative end, as most people are familiar with in electricity. And you have some sort of a feed line, usually coax or something like that. That's going to go down to a radio, and usually one side of the antenna is a quarter wavelength and the other side's a quarter wavelength. This is usually, this type of dipole antenna usually plays out exactly like that in HF radio. But really that's what all antennas are. So if you bought like a handheld radio, maybe a Baofeng or something like that, what you ended up having was this radio with this little stubby antenna sticking out the top, right? And just using a radio like this is not always awesome. But essentially what's happening here is this little stubby antenna up here is 1/4 wavelength for the frequencies that the antenna is resonant on, which if it's a Baofeng is kind of dubious sometimes how good that antenna is to begin with. And then the body of the radio, usually coupled with the person holding the radio, is the other quarter wavelength of the antenna. And then we have our connection right here in the middle. So we have a quarter wavelength going up the antenna, our connection in the middle, and our quarter wavelength down here, which is represented by the radio itself. And usually that's, this is like an ideal situation, because usually what this antenna actually is not even a full-length antenna. Usually it's this little stubby guy, and how it's built is like this coiled up piece of wire that goes up to an antenna to try to make it shorter, which is like a convenience factor, but doesn't help in actually working well. And then the other problem, so that's 1/4 wave is this coiled up bit with this little stubby thing. And the other problem is that like your radio is 90% plastic, and plastic is not an antenna, metal is. So you end up with a very bad situation really in terms of having efficient transmission from your radio. So what we're seeking to do with this project is to take this concept of this dipole antenna, which is a quarter wavelength, 2 halves of a quarter wavelength antenna, and somehow getting that connected down to our radio. And what we're going to be using is just coax cable that's probably just all over your attic and down in your basement from like 7 different cable companies, just running wire through your house and drilling holes through your hardwood floor and all kinds of nonsense. And you're just going to go chop some of that out of your house somewhere because you don't need that stuff anymore. And we have a couple different ways of using that coax. Now, whenever you're taking this coax out of your house, that's going to be 75 ohm coax, which we won't really get into what that means for the purposes of this video. But generally speaking, we're not using 75 ohm coax for radio applications. We're using 50 ohm coax. But I'll explain why that really doesn't matter here in a minute. Coax is made up of an outer protective sheath, a center conductor, which is transmitting your cable TV signal, and then on the outside of that center conductor and inside the overall sheathing is like this braid, and that braid serves to shield, it's called shielding, shield that center conductor from interference. But all of these components of the coax is what's going to end up becoming both our antenna and the feed line to the radio. All right, so we have our chopped off piece of coax. This is probably not framed well at all on this camera, so I apologize to begin with. And to simplify, you really have two options for connectors on Amazon. I'll link them both in the description. One of them is a type F to BNC adapter. So this would be like if your coax already has a type F connector that cable TV uses or satellite, and you're going to use that coax, well, you can just screw that straight on there. That's going to convert it to BNC. And then you just plug that straight into your radio. We're going to assume that you just have a chopped off piece of coax for this project, and we're actually going to be using a connector that you can literally just jam and thread this onto coax, and it's going to make the connection for your radio. So anyway, the first thing we need to do is figure out how to build this antenna. How long does it need to be? So if you have any interest in field radio whatsoever, you need to commit a formula to memory, which is the magic number, which is 234. 234 is the magic number. If you take 234 divided by the frequency in megahertz, that equals a quarter wavelength in feet. So if we take 234, which is a constant, it's the magic number, 234 divided by our frequency in megahertz, that equals our quarter wavelength antenna length in feet. So for the purposes of this project, let's just say we want 465 megahertz. We're going to be using frequencies somewhere around 465 megahertz, which if we make an antenna for 465 megahertz, it's probably going to be good from like 460 to 470, depending on a lot of things, but you're going to have some leeway, however much leeway, who knows, depending on a lot of things. So we're going to take 234 divided by our frequency in megahertz, which is 465, on our calculator. 234 divided by 465 megahertz equals 0.503 feet. Now we can figure out what that is in our head, but for the purposes of the demonstration, we're going to multiply that by 12 to get inches. So that's basically going to be 6.038 inches. Okay? So now we know how long a quarter wavelength antenna is for our frequency we want, 465 megahertz. And we're just going to round that down to 6 inches. This is going to be hard to see. So anyway, we'll just move over here. So our goal is to take this center conductor from the coax, make it 6 inches long. We're going to use the braid of the coax as the other 6 inches for the two sides of our dipole. And then we're going to have a section of this coax be the feed line down to our radio. Now, that's essentially what's going to be the center of the coax, the braid, and then some feed line down to our radio. All right. So what are we going to need? We're going to need our coax. We're going to need our connector off of Amazon, something to measure with, pliers, a pick or a pick-like thing. You'll see what we're going to do here in a minute, and a razor blade. So let's take our coax and we're going to measure 6 inches, right? We're going to cut this one directly at 6 inches, but if you're going to end up using the coax as also a support for how you're going to pull this up in a tree, maybe make that like an extra, I don't know, 3 inches longer, and then you can loop that over and kind of zip tie it together to make a loop. But there's a lot of different ways to make a something on the end to pull it up if you want to. You use your imagination, or look at a field manual. It shows you how to use plastic trash for antenna insulations for supports. So anyway, we're going to take our razor blade at 6 inches and we're going to score the outside of the coax, being careful not to go too deep, because directly underneath this outer jacket is the braid that's also a part of our antenna. So we don't want to go chopping that up with our razor blade. And obviously, if you're not making a video, you can take your sweet time doing this and you're not in a rush and be a lot less prone to making mistakes. So we're going to kind of score that around the outside at 6 inches. And then we're going to take our razor blade and we're going to score it all the way down to the end of the coax to help us get this black jacket off. Once again, being somewhat mindful not to damage the braid that's underneath, because we're going to be using it. Okay, so we have our outer jacket off, right? And that's trash. And now we can see that we can see what coax actually looks like, right? So this is our outer shielding, which in this case is this copper, right? We're just kind of loosen that up by jiggling it around. We want this nice and loose to help us with the next step. And you can see that our center conductor is protected by this insulation on the outside. We're going to make sure we don't damage this, in this case, white insulation, because we don't want this center conductor to short out against this braid. We need to keep these separate. So if we end up breaking this white insulation, you got to start over because we can't have that shorting out. But our goal here is to actually pull the center conductor out from the bottom, out from inside of this shielding. And we'll see how good we can do this on camera here. We're going to use our pick and kind of start making, just kind of pushing this braiding around. Once again, trying not to hurt it, but at the same time we have to make a hole in it to pull our center conductor through. So once we kind of have a hole started, we're going to try to use our pick to kind of get under there. We're going to start working this around so that we can get this pulled through. Also a good idea to wear glasses. So once we get it started through, kind of work it around. You know, this is all wiring, so it's kind of stiff. Take your time so that you're not damaging the braid. And just kind of work this around. And eventually, you're going to be able to pull the entirety of this center conductor of this coax out of the braid. So here we accomplish that, right? So as you can see, we now have these separated, and now we have our quarter wavelength resonator up here for our antenna, and now we have the other quarter wavelength of our antenna, which is the braid. I'm probably holding that up too high. So we have 1/4 wavelength here, 1/4 wavelength here. I would recommend that you just take some electric tape or whatever, heat shrink tubing, whatever you want to do, and just protect this braid. You can just pin it up against your coax, wrap some electric tape around it or something. Like I was saying, find some way to put a support here, some sort of loop, so you can pull this up in a tree if you want. Okay, so we're just gonna push that out of the way. And on this, if you're using 75 ohm coax from cable TV, don't make this feed line. So the rest of this coax can be your feed line to kind of get the antenna up in a tree away from your radio, get it up a little bit higher. But since we're using 75 ohm coax from cable TV, don't make it super long because that's going to upset your radio. So maybe like 2 feet, 3 feet at the most. But after that, if you want it longer, for whatever reason, get some actual radio coax, 50 ohm coax off of Amazon that can serve as an extension cable to this, which would be like a BNC female to male, you know. So here at the feed line end of our coax, you know, just, I don't know what this is, 1.5 inches or something like that down. Once again, we're going to score the outside jacket of the coax with our razor blade, being careful not to hurt the braid, you know. Wiggle it around, see where it needs to get cut again. Being careful not to hurt the braid. We're just going to cut this outer jacket. So once we have the outer jacket out, set that aside, that's trash. And here we're back to our coax again. What we're going to do this time with this braid is kind of feather it out. Feather it out away from that center conductor. Because on this actual connector for the radio side, wherever that ran off to, right here, whenever you plug in an antenna to your radio, if you look at the connector on your radio, it has a center pin and then a threaded portion on the outside. So that's literally the positive and negative of this system. So we're taking the center conductor and we're going to be connecting it to the center conductor of this connector. Then all of this shielding here is just attaches to the body of the connector as the ground side. So anyway, I'm going to take that shielding and just kind of push it down on the coax so that we're just left with the center conductor and that white insulation. Let me kind of get in close here. Then what we're going to do is we're going to go up maybe like 1/8 of an inch up here. And we're going to take our razor blade and score the insulation for the center conductor and take that off. So what you're going to end up with is your braiding, your ground side, about 1/4 inch buffer to make sure they don't short out, and then the center pin. So let's go ahead and do that. Go up about 1/4 inch, and we're just going to score that with our razor blade. Be careful not to go too deep and damage the wires that are underneath. And you can encounter a couple different kinds of coax, and these adapters off Amazon are pretty forgiving. Whether you're going to find a solid piece of copper for this connector inside, or if you find stranded, it really doesn't matter. This particular coax is stranded, so we're just going to twist it together to make it nice and tight. Okay, now we're going to look at what we've done here. We've made a center conductor, and we've pulled the ground away, and we've left a little bit of this insulation, this white insulation in between to make sure they don't short out. We're going to look at how our connector is built, and by just examining it, we can tell that the center conductor needs to basically go up to where this knurled end is. So we'll just hold it up, you know, next to approximately what we're trying to do here, and we'll just cut that to the length that we eyeball it at, which I'm guessing is about right there. So final product is going to end up looking somewhat like this. I hope you can somewhat see that. Who the hell knows? And whenever you look in the side here, you're going to see there's a hole. You're going to stick your center conductor in that hole, you know. You're going to feel it go in. Now this is just going to be a process of just brute screwing this on now. This whole end of this connector is just one big threaded nut, and it just wants to literally bite into this shielding on the coax and the outer sheathing of the coax and grip onto all that so that it doesn't fall apart. So you're really going to give this the business. And then give it a test tug to make sure it's on there good. Okay. When you get done, you're probably going to have a little bit of this grounding business left. Just take your end snips and just snip that off. That's not really going to hurt anything, but to make it look better, just snip that off. Give it a real good tug, and we're on. Okay, so build you some sort of a loop here to pull this up into a tree. Take your ground side, your shielding, electric tape that up to the side. Now you got your feed line going down, down, down. Plug this into your radio, which has been adapted to B and C, and now you have a field expedient antenna to use out in the field without having any special tools or soldering irons. All right, thank you.